Welcome back to our study of related rate problems. And we are tackling these problems in chapter 3 where we introduce the derivative. These problems could really be classified in the next chapter with applications of derivatives also, but I've done it both ways. But at some point you need to figure out how to tackle these type of problems. But anyway, what we have in front of us here is a related rates AP test question. I have about 30 years of these things. We're starting to get enough experience that you need to see what they expect of you on these tests. But here you go. They give you, here they tell you that is shown as 5 feet long. So here's some text here, and they give you, you see this is 5. You can read that. I'm not. That's 5, that's 2, that's 3. Okay, and water's being siphoned out of the trough at a rate of 2 cubic feet per minute. Pay attention to, when you read these things, I pay attention closely to units. So water's being siphoned out. So I guess dV/dt, I'm going to do a little work here, a little scribbling, dV/dt. So the volume of water in this thing is siphoned out, so it's getting smaller. So I might write that as negative 2, and I'm going to keep this. The units, make sure I don't misclassify what that is. I might think, oh, that was the height or that was the area. No, it's cubic feet. It's got to be volume. At any time t, let h be depth and v be the volume of water in the trough. Okay, got it. So I got a picture. They've kind of given me a picture. I'm going to call this, though, I do want to label. Remember, label my variables. I'm going to call this, that's going to be height. Okay, that's going to be height. And why don't we call this distance here, that I'll just call, I don't know, width. That's the width of the water. Okay, I'll draw that little triangle a little closer. We'll take that on another page. But okay, now what you'll see in AP questions, a lot of times they're going to guide you to the real question they want you to answer. So they ask you part A. They say, find the volume of the water in the trough when it is full. Okay, well, remember what this is going to be. It's going to be this base area here. It's going to be the base area of the triangle, which is what they're calling this. The height of this thing is 3. The width is 2. The width is 2. So the area of that triangle is what? 1/2 the base times the height. It's going to be 3. The area of that triangle is 3. 3 times this width here, so it's going to be 15. The volume is going to be 3 times 5, or maybe I just call it the area of the triangle times 5. Okay, equal to 15. Now they want to know, what is the rate of change in H at the instant when the trough is a quarter full by volume? A quarter full by volume, that means what? Well, that means when volume is 1/4 of 15. What do they want to find? They want to find dH/dt. Okay. All right, I want to go to a new page and draw this out, because I want to know, I want to find this. Again, what do I know? Well, I know this. Equals -2. Okay, let's draw this. We need a relationship now between the volume and the height. And this is, you might not see this initially. And here's something we call, this is the side section of this thing. And what did they tell me? This is, Got to remember this now. This height here is 3. This is 2. This is 2. Now here, that's when the trough is completely full. Let's change pens. Now, what is this? What is this width going to be to that height? Okay. And what you got to see is that this outside triangle here, something you learned in geometry a while back, the outside triangle is a similar triangle to this inside triangle. That means the ratio, that means what? These are similar triangles, which means the ratio of the sides are equal. So that means W over H is equal to 2 over 3. W over H is equal to 2 over 3. We know volume. Remember what we know. Let's put this down. dV dt is equal to minus 2. What are we trying to find? Well, we're going to try to find dH dt. I've labeled everything. Now I want what? What do I need to find? Well, I need to find volume as a function of H. This is what I need. I need this relationship. And as I told you, that's why it's called related rates. Relationship between V and H. All right. Well, let's look at this. What's volume going to be? The volume is going to be this area here, the area of this triangle. This triangle is what? Well, it's going to be 1/2 the base W times the height times what? Remember the picture? This thing is 5. This isn't changing. Times 5. Times 5. Okay, so times 5. Well, I got a problem here. Sure, I got volume and I've got W, but what about H? This is the bugaboo. In case you were wondering, I need that's changing with time too, right? The width is getting smaller with time. This is a function of time. That's a function of time. But what do I know here? Well, here's this guy comes into play. I could say W is equal to 2/3 H, right? W is equal to 2/3 H. So now I plug that into here, and I get what? I get V, and I'll put this in a new, because this is really the whole problem right here. V is equal to, I'm going to put 5/2 times 2/3 H times H, which is going to be equal to what? 10/6. We'll cancel that out, I guess. 5/3 H squared. Oh, there you go. There you go. There's my relationship between dV dt, between volume and the height. Now, what do? I take a derivative. Okay, so I found my relationship. I found the kind of the hard part here. Go back here. In this, I got volume is equal to 5/3 H squared. What am I looking for? I'm trying to find dH dt. Well, my next step then is to what? Take the derivative of both sides. I'm going to take the derivative of this with respect to time, and I'm going to take the derivative of this with respect to time. Notice what? Well, this is the height of the water is changing with time. So I could really write it like that, right? And so is the volume is changing with time. So I write this as dV dt. I don't explicitly put in the function of time. And then how do I take the derivative of this? Well, it's 5/3 5/3. Now I got a chain rule on this, right? I got a chain rule on this problem. So after you've done all this work, don't make a chain rule error because you've done the hard part. I take the derivative of this. The derivative of the outside function, well, this is just a function squared. So it's going to be 2 times h of t. I could put the t in there. Okay. Times, well, what's the derivative of the inside? Oh, it's dh dt. dh dt. Okay. Now, if you so what? I know this. I know dv dt. This is minus 2. And notice that's minus 2 what? What was it? Minus 2 feet. Let's look at that again. Remember, I like to look at units. Cubic feet per minute. 2 feet cubed per minute. Now that better match the other side too, right? This is 5. Remember where that 5 comes from? That's the length of this trough. This is 5 right here. So that's 5 feet. That's 5 feet. So this is feet. There's a unit of feet here. H is in feet. dH dt is feet per second, right? dH dt. So look, feet per second. I'm getting a cubic feet. If you had happened to have forgotten dH dt when you took your derivative, guess what? When you checked your units, it wouldn't have worked out. You would have got just feet squared. So in case you'd forget to take that derivative, if you check your units, you can catch errors. I always like to be able to do that if I can. Okay, what is h here? Question is, okay, so I got what? I got 10 thirds h dh dt. Okay, well, this is what I want to find. What's h? What's h? Well, let me go back and read this problem again. They're saying, what is the rate an h at the instance when the trough is a quarter full by volume? A quarter full by volume. Okay, what's h equal to when it's a quarter full? Okay, so let's go back up here. I guess that's what this is. Remember this. This is volume is 5/3 h squared. If this is, what did we say? It was full. If it's full, it's 15. So 15 divided by 4 is equal to 5/3 h squared. Now I'm solving for h. At the instant it's a quarter full, it's what? Well, it's going to be 3/5 times 15/4 equal to h squared. This looks like it's 9/4 is equal to h squared. Or if I take the square root of both sides, I'm going to get 3/2 is equal to h. So they gave me what h was at the time I'm interested in a kind of a hidden way. So I had to do a little work to find h. So here, if h is 3/2, I plug into this. This is 3/2, and now, well, let's find it. Let's get that moment of triumph if we get this right. So I'll change pens to go in for the kill here because I think I got this problem where I want it. I got minus 2 times 2/3 times 3/10 should be equal to dH dt. So let's see, that's canceling with that. I'm looking at like minus 4/10 is equal to dH dt, or equal to minus 2/5. What would my units be? It should be feet per minute. Oh, this is minutes up here, sorry. Yeah. So dH dt should be minus 2/5 feet per minute.